Hello students, welcome to Yupp Master. I am Radha Krishna, your mathematics teacher. Our today's topic is continuity and differentiability. Continuity, differentiability and differentiation. First, let us have a look at some theory points about continuity. A function f of x is said to be continuous at x is equal to a if limit of f of x as x tends to a is equal to f of a. What does it mean? If you take the graph of a function like this, at a point say x is equal to a, at x is equal to a, if f of a is defined, then the point is defined. If this limit is defined, that means immediate right neighborhood point and left neighborhood point are existing. Now, if this point is connected to both right side curve and left side curve, then right hand limit and left hand limit will be equal to f of a. Okay. And suppose, and this is one kind of example, and another example, the graph can be like this, having a sharp corner at x is equal to a. At this point is defined and it is connected to right side curve and left side curve, then it is continuous at x is equal to a. Now, if limit of f of x as x tends to a plus is equal to f of a, this is called right hand limit. If the right hand limit is equal to f of a, then the function is said to be right continuous at x is equal to a. Now, if you take the graph of a function like this, suppose the graph is like this, at x is equal to a, if the point is connected to right side curve only, then it is said to be right continuous. If the point is connected to right side curve, then right hand limit will be equal to f of a. Okay. Next, if left hand limit is equal to f of a, then it is said to be left continuous. That means, if the same point is connected to left side curve, then it is said to be left continuous at x is equal to a. Next, let us see the classification of discontinuities. There are two kinds of discontinuities, first kind and second kind. In first kind, again two types, removable, non-removable. Again in removable, missing point discontinuity and isolated point discontinuity. So, what is missing point discontinuity? Suppose the graph of a function is like this, at x is equal to a, then one point is missing, so the function is discontinuous at x is equal to a. This kind of discontinuity is called missing point discontinuity. Now, what is isolated point discontinuity? At x is equal to a, if f of a is defined here, the point is isolated, it is not connected to right side point or left side, right side curve or left side curve, then it is said to be isolated point discontinuity. Non-removable discontinuity, if you take this kind of discontinuity at x is equal to a, this is called non-removable discontinuity or jump discontinuity. The function suddenly jumps from a minus to a plus. Okay, when x changes from a minus to a plus, there is a jump. This is called magnitude of the jump. In this case, left hand limit is not equal to right hand limit. So, whenever left hand limit is not equal to right hand limit, it is called non-removable discontinuity or jump discontinuity. Okay. Next, discontinuity of second kind. Infinite discontinuity and oscillatory discontinuity. Infinite discontinuity is this kind of discontinuity. Suppose there is a curve like this. when x is 0 minus, it is tending to plus infinity. When x is 0 plus, it is tending to plus infinity. So, it is discontinuous at x is equal to 0. At x is equal to 0, value is not defined. Even if it is defined, it cannot connect, it cannot be connected to both right side curve and left side curve, because both sides it is approaching infinity. This kind of discontinuity is infinite discontinuity, and oscillatory discontinuity is a discontinuity of this kind. Suppose there is a function like this, it is oscillating, fastly it is oscillating. So, at this point the function is said to be having oscillatory discontinuity. Okay. Now, some points about differentiability. The first definition of a derivative is f dash a is equal to limit as x h tends to 0 f of a plus h minus f of a by h, or limit as x tends to a f of x minus f of a by x minus a. This is the definition of a derivative of a function at x is equal to a. Now, right hand derivative of the function at x is equal to a is denoted by f dash a minus a plus. It is right hand limit of this function, limit as x tends to a plus f of x minus f of a by x minus a. Similarly, left hand derivative at x is equal to a is f dash a minus, it is equal to limit as x tends to a minus f of x minus f of a by x minus a, or we can take h tends to 0 plus for right hand derivative and h tends to 0 minus for left hand derivative in this formula. Now, a function is said to be differentiable at x is equal to a if f dash a exists. If f dash a exists, then this limit exists, this or this, then the function is said to be differentiable at x is equal to a. That means right hand derivative should be equal to left hand derivative. Okay. So, these are the important points about continuity and differentiability. Now, let us start the problems. The first problem, find the interval in which f of x is equal to integral part of x into cos of 2x minus 1 into pi by 2 is continuous. F of x is equal to integral part of x into cos of 2x minus cos of 2x minus 1 into pi by 2. Okay. We know that cosine function is continuous everywhere. You know the graph of cos x, it will be continuous everywhere, and integral part of x, our greatest integer function, is discontinuous at every integer. So, this part is continuous everywhere. So, it may become discontinuous only when this is discontinuous, but we are not sure. So, there is a possibility of discontinuity at integral values of x only. Okay. So, let us consider an integer n. Let x is equal to n be an integer. Now, I am verifying the continuity at x is equal to n. First, f of n is equal to, what is the integral part of n? It is n into what is cos of 2n minus 1 into pi by 2? It is 0. So, f of n is 0. Now, let us verify left hand limit and right hand limit. Limit as x tends to n minus f of x is equal to, when x tends to n minus x is just less than n, then what is the integral part of x? It is n minus 1. N minus 1 into, again this is, there we can directly substitute, because it is a continuous function, we can directly substitute x is equal to n. Then what you will get? Cos of 2n minus 1 into pi by 2, 0. So, when x tends to n minus, it is 0. Okay. Next, when x tends to n plus, when x tends to n plus, integral part of x is n, and cos of 2n minus 1 into pi by 2 is 0. So, it is 0, f of n is 0 and right hand limit is 0, left hand limit is 0. So, all these are equal. So, function is continuous at x is equal to n. That means, it is continuous at all integral values also. Okay. Hence, the interval where it is continuous is all real values, or this is the answer. Next question, find the number of integers at which f of x is equal to integral part of x square minus integral part of x whole square is continuous. We want number of integers only. So, we have to verify the continuity at integral values only. So, again you take an integer n. Let x is equal to n be an integer. Now, first f of n is equal to integral part of n square is n square, integral part of n is n, so it is also n square, it is 0. Next, left hand limit and right hand limit. Limit as x tends to n minus f of x. If x tends to n minus, x square tends to n square from left side. So, its integral part is n square, sorry, n square minus 1, right. X square tends to n square from left side. So, its integral part is n square minus 1 minus, when x tends to n minus, x is just less than n, then integral part of x will be n minus 1. So, it will be n minus 1 whole square. Then it is n square minus 1 minus of n square minus 2n plus 1. So, what happens? N square cancels, you will get 2 into n minus 1. Okay. Now, right hand limit. Limit as x tends to n plus f of x is equal to, if x tends to n from right side, x square tends to n square from right side. So, what is the integral part? It will be n square. If x tends to n from right side, integral part of x will be n. So, this is n square, it is 0. So, right hand limit is always 0 for any value of n. It is equal to f of n. Right hand limit is equal to f of n. That means, it is always right continuous. At every integral value, it is right continuous. But we want the number of integers where it is continuous. If it is continuous, this left hand limit should also be equal to 0. So, if this is 0, then f of n is equal to right hand limit is equal to left hand limit. If this is 0, there is only one integral value, n is equal to 1. So, the number of integers at which it is continuous is 1. Answer is 1. Okay. Next question, find the domain of the derivative of f of x is equal to tan inverse x if mod x is less than or equal to 1 and half into mod x minus 1 if mod x is greater than 1. What is the meaning of domain of the derivative of the function? It is nothing but the interval in which the function is differentiable. Okay. First, let us write the definition piecewise. Already it is piecewise, but I want to remove this mod. Then f of x is equal to, first take the interval minus infinity to minus 1. If x belongs to, or if x is less than minus 1, then mod x is greater than 1. If x is less than minus 1, mod x is greater than 1, then we have to take this. But when x is negative, mod x will be minus x. So, it will be half into minus x minus 1, right. Next, if minus 1 less than or equal to x less than or equal to 1, then we have to take this definition because mod x is less than 1. Then write tan inverse x. Next, if x is greater than 1, again mod x will be greater than 1, we have to write this, but x is positive, so mod x will be plus x. So, it will be half into x minus 1. Now, we want the interval where it is differentiable. Okay. If you take this interval, this is a linear function. Linear function is differentiable everywhere. Graph of a linear function is a straight line. It is differentiable everywhere. It will have slope at every point. So, in the interval minus infinity to minus 1, it is differentiable. Next, in the interval minus 1 to plus 1, tan inverse x is differentiable because graph of tan inverse x will be a smooth curve. Whenever the graph is a smooth curve, the function is differentiable. So, graph of tan inverse x will be like this. So, it is differentiable in the interval minus 1 to 1. If x is greater than 1, again it is a linear function, differentiable. So, we need to check the differentiability at minus 1 and plus 1 where the definition is changing. At remaining points, it is differentiable by observation. At minus 1, if you want to know whether it is differentiable or not, first we should check the continuity, because if the function is discontinuous, automatically it is not differentiable. Okay. So, first we need to check the continuity. If it is continuous, then only we will check the differentiability. How to check the differentiability? We will check the left hand derivative and right hand derivative. So, if you check the continuity, what is the left hand limit as x tends to minus 1? You substitute x is equal to minus 1 here. What are you getting? 0. If you substitute x is equal to minus 1, this is 0. So, at minus 1, left hand limit is, I can write left hand limit like this, limit as x tends to minus 1 minus f of x can be written like this. This is 0, this is left hand limit, and right hand limit is f of minus 1 plus. How do we get? When x is just greater than minus 1, this is the definition. So, substitute x is equal to minus 1 here, tan inverse minus 1, it is minus pi by 4. These two are not equal. So, function is discontinuous at x is equal to minus 1. Okay. Next, at x is equal to 1, the definition changes. At x is equal to 1, f of 1 minus means left hand limit. Substitute x is equal to 1 in the left hand side definition. When x is just less than 1, we have to take this definition. putting x is equal to 1, what are you getting? Tan inverse 1 pi by 4, and right hand limit f of 1 plus, we have to substitute x is equal to 1 here. How much are you getting? 0. These two are not equal. So, it is not differentiable. It is discontinuous, hence not differentiable. Okay. So, what is the interval in which it is differentiable? It is differentiable everywhere except -1 and +1. So, answer is or minus of -1 and +1. But if you directly check the differentiability, what happens? Let us see. If you want to check the differentiability, we have to check left hand derivative and right hand derivative. What is the left hand derivative at -1? Directly differentiating this, you will get -1 by 2. That means it is f dash -1 minus, it is -1 by 2. And if you calculate right hand derivative, f dash -1 plus, means we have to directly differentiate this. What is the derivative of tan inverse x? 1 by 1 plus x square, and putting x is equal to -1, you will get 1 by 2. So, they are not equal. At x is equal to 1, if you do the same, f dash 1 minus, at 1 minus you have to take this definition, differentiate it and put x is equal to 1. If you differentiate 1 by 1 plus x square, putting x is equal to 1, you will get 1 by 2. And f dash 1 plus, you have to differentiate this. What is the derivative? 1 by 2. So, here you are getting equal values. So, you may think that it is differentiable at x is equal to 1, because left hand derivative is equal to right hand derivative. But actually this left hand derivative or right hand derivative are not defined, because it is not continuous. So, without verifying the continuity, you should not go check the differentiability. Okay. Next question. Which of the following functions is differentiable at x is equal to 0? The options are cos mod x plus mod x, cos mod x minus mod x, sin mod x plus mod x, and cos mod x minus mod x. Sorry, this is also sin. Okay. Now, we know that cos of mod x is cos x, because cos of minus x is cos x. So, if you take the first option A, f of x is equal to cos x plus x. You write it, we want the differentiability at x is equal to 0. So, I will write the definition when x is negative and x is positive separately. When x is negative, it will be cos x minus x. When x is less than or equal to 0. When x is positive, it will be cos x plus x. If x is greater than or equal to 0. Okay, I wrote equality at both the cases, because both are same for x is equal to 0, you can see. Now, if you want to know about differentiability, first you check the continuity. Put x is equal to 0 here and here, are you getting the same value? Cos 0 is 1 minus 0, here 1 plus 0, it is same. So, it is continuous, and actually no need to check the continuity, because you know that modulus function is continuous, cosine function is continuous, sine function is continuous. So, all these functions are definitely continuous. Okay. So, no need to check the continuity. So, directly we will go for differentiability. How to check the differentiability at 0? At 0, f dash 0 minus left hand derivative. if you want, you directly differentiate and put x is equal to 0. Derivative of cos x is minus sin x minus 1, minus sin x minus 1. Put x is equal to 0, what are you getting? Minus 1. Similarly, f dash 0 plus right hand derivative. You have to differentiate this and put x is equal to 0. Differentiating this, you will get minus sin x plus 1. Putting x is equal to 0, how much are you getting? Minus sin 0 plus 1. Sin 0 is 0, so you will get 1. These two are not equal, so it is not differentiable at 0. Okay, so this is not correct. Now, if you check the option B, when x is negative, it will be, for option B, when x is negative, it will be cos x plus x, because mod x is minus x. When x is positive, it will be cos x minus x. Then in the same way, if you check the differentiability, f dash 0 minus, when 0 minus, it is cos x plus x. If you differentiate, you will get minus sin x plus 1. Putting x is equal to 0, you will get plus 1. F dash 0 minus is plus 1, and f dash 0 plus will be minus 1. Differentiating this and putting x is equal to 0. So again, right derivative and left derivative are not equal. So this is also discontinuous, not differentiable at x is equal to 0. Now check the next option C. F of x is equal to, if x is greater than or equal to 0, sorry, first less than or equal to 0 we will write. If x is less than or equal to 0, then mod x is minus x. Sin of minus x minus x. Sin of minus x is minus sin x minus x. When x is greater than or equal to 0, mod x is plus x, so it will be sin x plus x, right. Now do the same, no need to check the continuity. F dash 0 minus, you differentiate this, what are you getting? Minus cos x minus 1. Differentiating the first one. Putting x is equal to 0, what are you getting? Minus cos 0 minus 1. Cos 0 is 1, so it will be minus 2. Next, f dash 0 plus. Differentiate this and put x is equal to 0. Derivative of cos x is sin x is cos x plus 1. Put x is equal to 0, what are you getting? Plus 2. Minus 2 and plus 2, they are not equal. So it is not differentiable at x is equal to 0. So this is also wrong, discontinuous. So obviously the answer must be D, sin mod x minus mod x, but let us check. For option D, when x is less than or equal to 0, it will be sin of minus x minus sin x minus of minus x plus x. When x is greater than or equal to 0, it will be sin x minus x. Now if you differentiate, you will get minus cos x plus 1, left hand side. Put x is equal to 0, what are you getting? 0. Minus cos 0 plus 1 is 0. Now when x is greater than 0, This is the definition. So, for f dash 0 plus, differentiate this cos x minus 1. Putting x is equal to 0, what are you getting? It is also 0. F dash 0 minus is equal to f dash 0 plus. So, it is differentiable at x is equal to 0. So, answer is option D. Next question. Let Z be the set of all integers and n belongs to Z and P be a prime number if f of x is equal to integral part of n plus p sin x. Find the number of points at which f is non-differentiable in the open interval 0 to pi. F of x is equal to in integral part, if you have an integer, we can take it out. So, I will take n outside the integral part plus integral part of p sin x, right. Now, we know that greatest integer function integral part of x is discontinuous at every integral value. Its graph will be like this. At every integral value, it is discontinuous, is it not? So, this is discontinuous whenever x is an integer. So, this will be discontinuous whenever p sin x is an integer. Okay. What are the integral values of p sin x? You know that in the interval 0 to pi sin x is positive. So, sin x lies between 0 and 1. 0 less than sin x less than or equal to 1 in this interval. So, p sin x lies between 0 and p. We know that it is discontinuous whenever p sin x is an integer. So, let us write the integral values of p sin x. F of x is discontinuous when p sin x is equal to, what are the integral values? 1, 2, 3 and so on p. Okay. Then what are the values of sin x? Sin x is equal to 1 by p, 2 by p, 3 by p and so on, p minus 1 by p and then 1. These are the values of sin x. At all these values of sin x, function is discontinuous. Now, we want the number of values of x at which it is discontinuous, sorry, not differentiable. Actually, when it is discontinuous, automatically it is not differentiable. Greatest integer function, if you see, at every integral value of x, it is discontinuous, so not differentiable. At remaining points, it is continuous and differentiable. Okay. Here, we want the number of points at which it is non-differentiable in the interval 0 to pi. So, whenever this is an integer, it will be discontinuous as well as not differentiable. So, f of x is not differentiable when p sin x is an integer. So, sin x will have these values. Now, we want the number of values of x where it is non-differentiable. If you take sin x is equal to 1 by p, in this interval how many values of x will be there? One value in 0 to pi by 2, another value in pi by 2 to pi, is it not? So, there will be two values of x for 1 by p. Similarly, for 2 by p also we will get 2 values. Similarly, up to p minus 1 by p, for each we have 2 values of x where it is non-differentiable. So, p minus 1 into 2 values of x, but for sin x is equal to 1 there is only one value, x is equal to pi by 2. So, that value plus 1. So, total number of points where it is non-differentiable is 2p minus 1. Okay. So, answer is 2p minus 1. Go to next question. F of x is equal to ax cube plus bx square plus cx plus d has real zeros alpha, beta, gamma such that 0 less than alpha less than beta less than gamma. Find the number of points at which mod f of mod x is not differentiable. Sometimes we can tell points where it is non-differentiable by graph. In the graph, if there is a discontinuity, it is not differentiable, and even if it is continuous, if it is a sharp corner like this, at this kind of points it is not differentiable, okay, because right hand derivative is not equal to left hand derivative. Right hand derivative means at this point, if you can draw a tangent like this, it can be called as right hand tangent, and we can draw one line just like this. The slope of this line is left hand derivative, slope of this line is right hand derivative. Clearly they are not equal. So, at this kind of corners, sharp corners, function is not differentiable. So, to tell the number of points where it is not differentiable, let us draw the graph. It is a cubic polynomial and it has 3 real zeros. Real zeros means real roots. So, if f of x is equal to 0, we have alpha, beta, gamma, and all are alpha, beta, gamma all are positive. So, the graph of f of x will be if you take this as alpha, this as beta, this as gamma, the graph of f of x will be like this, intersecting the x axis at alpha, beta, gamma, or it can start from infinity and intersect the x axis at these 3 points and go to minus infinity. That depends on a. If a is positive, this is the graph. If a is negative, it will be like this. You can take any one. Now, this function is mod f of mod x. How to get the graph of mod f of mod x from the graph of f of x? This is y is equal to f of x. First, if you replace x by mod x, what happens? If you replace x by mod x, the right hand part remains as it is, but the left hand part should be removed, and we should draw the reflection of the right hand part in left side. So, the graph of y is equal to f of mod x will be like this. Right hand part remains as it is and left hand part should be removed, and you should draw the reflection of the remaining part about y axis, y axis. It will come like this. Okay, this is the graph of y is equal to f of mod x. Now, if we take whole mod y is equal to mod f of mod x, then what to do? We have to remove the graph below the x axis and draw its reflection about x axis. So, first this part should be removed and we should reflect it. So, what happens? I will draw here itself. So, this must be reflected here like this and we should remove this. Okay. Similarly, this must be removed and we should draw its reflection. Okay, it is reflected. Again, remaining graph will be like this. That one, it will come like this. Okay. So, at how many points it is not differentiable? So, count the number of sharp corners 1, 2, 3, 4, 5, 6, 7. So, the answer to this question is 7. Okay. Now, next question. So, this is a very good question. Let f of x be equal to x square minus 2 mod x and g of x be minimum of f of t with minus 2, minus 3 less than or equal to t less than or equal to x, and when minus 3 less than or equal to x less than 0, it is maximum of f of t when 0 less than or equal to t less than or equal to x and 0 less than or equal to x less than or equal to 3. Then find the points at which g of x is not differentiable in the interval minus 3 to 3. First you draw the graph of f of x. What will be the graph of f of x? First you draw the graph of x square minus 2x. Graph of x square minus 2x will be a parabola. It is an upward parabola intersecting the x axis at 0 and 2. It intersects the x axis at 0 and 2. Okay. Now, if I replace x by mod x, it becomes this. When you replace x by mod x, already we have discussed in the previous question. When x is replaced by mod x, what happens? Right side part remains as it is. This must be removed and we should draw the reflection of right side part. So, if you take mod x whole square is same as x square minus 2 mod x, then what happens? This must be removed and this must be reflected. So, it will come like this. So, finally, the graph of f of x will be like this. Okay. Now, this is 0, this is 2, this is minus 2. Okay. The asked interval is minus 3 to 3. This is minus 3, this is plus 3. Okay. Now, t lies between minus 3 and x. Suppose, and what is this minimum point? This is minus 1. At minus 1 we will have a minimum value, here at 1 it will have a minimum value. Now, look at this part. Suppose x is between minus 3 and minus 1, okay. Then t will be between minus 3 and x. Suppose t is here, this is t. Then as t varies between minus 3 and x, what is the minimum of f of t? What is the minimum of f of t? It will be f of x only, is it not? In this interval, when t varies between minus 3 and x, what is the minimum of f of t? It will be f of x only, no? So, if minus 3 less than or equal to x less than or equal to minus 1 till minus 1, the minimum of f of t is f of x. So, g of x will be f of x. F of x means x square minus 2 mod x, but x is negative. So, I will write x square plus 2x, mod x is minus x. Now, minus 3 to minus 1 definition is over for g of x. Now, consider x between x between minus 1 and 0. If x is between minus 1 and 0, t lies between minus 1 and x. So, when t changes between minus 1 and x, what is the minimum of f of t? It will be here, this point will be the minimum. What is the minimum value? It is f of minus 1. How much? F of minus 1 is 1 minus 2, it is minus 1. When x lies between minus 1 and 0 and when t lies between minus 1 and x, the minimum of f of t will be this point. So, it will be minus 1, g of x will be minimum of f of t, it is minus 1 if minus 1 less than or equal to x less than 0. Understood? Now, coming to 0 to 1, if x lies between 0 and 1, then t lies between 0 and x. Then in this interval, f of x is g of x is maximum of f of t. So, if you observe the values of f of t in this interval, what is the maximum? It is here at 0. So, maximum value will be 0 if 0 less than or equal to x less than or equal to 1. Till 1 maximum is 0 only. Now, starting from 1 up to 3, if x is somewhere here, if t changes between these two, what is the maximum value of f of t? In this interval, the maximum value of f of t will be f of x. F of x means this function. So, it will be if 1 is less than x less than or equal to 3. In this interval, it is f of x only. F of x means x square minus 2x, because x is positive, I am removing the mod. It will be x square minus 2x. So, this is the complete definition of g of x. Now, if you want to draw the graph, I will change this to the graph of g of x. In the interval minus 3 to minus 1, it is the same graph. this black one is the graph of g of x. In the interval -1 to 0, it is constant -1. So, it comes like this. In the interval 0 to 1, it is 0. Okay, 1 minute. Here, when x is between -1 and 2, in this whole interval maximum value is 0. Suppose x is between 0 and 2. If x is between 0 and 2, t varies between 0 and x, maximum value is 0. So, this is up to 2 and this is 2 to 3. Okay. So, 0 to 2, the graph will be like this. It is 0. From 2 to 3, it is f of x. So, this black one is the graph of g of x. Now, at what points it is not differentiable in this interval? Observe the sharp corners. This is not a sharp corner, it is a smooth bend. At 0 it is discontinuous, so at 0 it is not differentiable, 1 point, and this is a sharp corner. This is second point. So, totally it is not differentiable, g of x is not differentiable at x is equal to 0 and x is equal to 2. X is equal to 0 and x is equal to 2. This is the answer. Okay. Now, let us proceed to next question. F of x is equal to b sin inverse x plus c by 2 when x is between -half and 0, and it is half when x is 0, it is e power ax by 2 minus 1 by x when x is between 0 and 1 by 2. If f is differentiable at 0 and mod c is less than 1 by 2, find the value of a plus 64b square plus c square. If you consider the separate intervals, in this whole interval sin inverse of x plus c by 2, it is differentiable because sin inverse x is differentiable everywhere in its domain. Therefore, in this interval it is differentiable. In this interval, you can differentiate by u by v formula, you can differentiate. He said only differentiability at x is equal to 0 only, so no need to check the other values. At 0, if it is differentiable, first it should be continuous. If it is continuous, left hand limit should be equal to right hand limit should be equal to f of 0. F of 0 minus means left hand limit should be equal to f of 0 should be equal to f of 0 plus. What is f of 0 minus? Substitute x is equal to 0 here. You will get b sin inverse c by 2. F of 0 is given as 1 by 2. F of 0 plus. What is the limit of this when x tends to 0? Yesterday we discussed standard limits. This standard limit is a by 2. Okay. So, directly we are getting the value of a as 1, and from the other you cannot get any kind of polynomial like this. So, let us leave it. Now, going to differentiability. At 0, left derivative should be equal to right derivative because it is differentiable at 0. Left hand derivative is f dash 0 minus. How to calculate? We will directly differentiate this and put x is equal to 0. What is the derivative of? I will calculate separately and substitute it there. Derivative of b sin inverse x plus c by 2 is b by root over 1 minus x plus c by 2 whole square into derivative of x plus c by 2 1 by 2. Now, putting x is equal to 0, if this is 0, what will you get? 2 cancels, b by root over 4 minus c square. Okay. Now f dash 0 plus, you have to differentiate this, but if you differentiate by u by v rule and put x is equal to 0, 0 will be there in the derivative in the denominator, so you cannot substitute x is equal to 0 and get something. So we do not differentiate this directly, we write the expansion of e power ax by 2, already we got a is equal to 1 now, we can substitute here, e power x by 2 minus 1 by x is equal to, what is the expansion of e power x by 2? 1 plus x by 2 plus x by 2 whole square by 2 factorial is x square by 8 plus x cube by x cube by 8 by 3 factorial. So 3 factorial is 6, 8 6s are 48 and so on. Okay. This minus 1 divided by x. So cancel 1, cancel x, you will get 1 by 2 plus x by 8 plus x square by 48 and so on. Now if you differentiate, and put x is equal to 0, what will you get? Derivative of 1 by 2 is 0, derivative of x by 8 is 1 by 8 and remaining terms will be 0. So we are going to get 1 by 8. If it is differentiable at x is equal to 0, this should be equal to this. So this is equal to 1 by 8. Now cross multiplying and squaring, 8b whole square is 64b square is equal to 4 minus c square. So 64b square plus c square is 4. The asked question is a plus 64b square plus c square, a is 1, so adding a here, the answer is 5. Answer is 5. Next question. If f of x is equal to x cube plus e power x by 2 and g of x is the inverse of f of x, find g dash 1. Very nice question, it is actually a previous JEE question. Here it is not possible to find the inverse of this function, but we can find the derivative of the inverse function. If g of x is f inverse x, then f of g of x will be equal to x. Now differentiate, you will get f dash g of x into g dash x is equal to 1. Now put x is equal to 1, f dash g of 1 into g dash 1 is 1. What is the value of g of 1? Okay, if you want g of 1, suppose g of 1 is some a. If g of 1 is a, then it is equal to f inverse x. F inverse 1. It is f inverse 1 from this. So, we will get f of a is equal to 1. What is f of a? A cube plus e power a by 2 is equal to 1. By observing it, you can tell the value of a, how much? A is 0. So, a is equal to 0. So, this will be f dash 0 into g dash 1 is 1. What is f dash 0? Directly differentiate it. F dash x is equal to 3x square plus e power x by 2 into 1 by 2. Putting x is equal to 0, f dash 0 will be 1 by 2. So, 1 by 2 g dash 1 is 1, therefore, g dash 1 is 2. Okay. Now, moving to next question. If y is equal to x tan inverse x by y, find dy by dx. Options are given. This kind of function is called implicit function, and for implicit function, what is the method of finding dy by dx? If you take an implicit function, f of x comma y is equal to c, then dy by dx is equal to minus of dou f by dou x by dou f by dou y. Now, if you take this function, you can write it as y minus x tan inverse y by x, x by y. Is equal to 0. You take it as f of x comma y, then minus of, what is dou f by dou x? Partial derivative with respect to x, this is 0, minus, if y is constant, what is the derivative? 1 into tan inverse x by y plus x into derivative of tan inverse x by y is x into 1 by 1 plus x square by y square into 1 by y divided by partial derivative with respect to y. Derivative of y is 1 minus x is constant, so it is as it is. Derivative of tan inverse x by y with respect to y is 1 by 1 plus x square by y square into derivative of x by y with respect to y is minus x by y square. Now, let us simplify it. Minus of minus is plus. We can write tan inverse x by y as y by x plus this will be xy by x square plus y square by denominator 1 minus into minus is plus 1 plus what is it, x square by x square plus y square. Now, if you take y by x common from numerator, remaining will cancel out. So, answer is y by x, answer is C, but we can solve it in a very easy way. The given function is y by x is equal to tan inverse x by y. Let us take y by x as t. If y by x is t, then it becomes t is equal to tan inverse 1 by t. It is an equation, it will have a solution, maybe imaginary solution or real solution, it will have a solution. So, that solution is, say, t is equal to c, c is some constant. Then t means y by x. So, y by x is constant. So, we will get y is equal to cx. Then differentiate it, dy by dx will be c. dy by dx is c. What is c? It is y by x. So, answer is y by x. That means, if the whole function is in terms of y by x, whatever is the function, dy by dx will become y by x only. Whatever function you take which is completely in terms of y by x, dy by dx will be y by x. Okay. Now, we are going to take up questions and answer session. One question is, f of x is equal to fractional part of x plus 1 by 3 into integral part of sin pi x when x lies between 0 and 1. It is, and integral part of 2x into signum of x minus 4 by 3 if x lies between 1 and 2. Okay. I will write it again. F of x is equal to fractional part of x plus 1 by 3 into integral part of sin pi x when 0 less than or equal to x less than 1. It is integral part of 2x into signum of x minus 4 by 3 if 1 is less than or equal to x less than or equal to 2. At x is equal to 1, f of x is continuous and differentiable, continuous but not differentiable, neither continuous nor differentiable, everywhere differentiable. Let us check the continuity first. At x is equal to 1, what is the value of f of 1? F of 1 means you have to substitute 1 here. Integral part of 2 into 1 is 2 into signum of 1 minus 4 by 3 is signum of minus 1 by 3. What is the signum of minus 1 by 3? It is minus 1. When something is negative, its signum value is negative 1. When something is positive, its signum value is plus 1. Signum of 0 is 0. So, this is minus 1. So, f of 1 is minus 2. Now, limit as x tends to 1 plus f of x. Here you will take f of x as this function only. So, obviously, integral part is there now, okay. It is equal to, when x tends to 1 plus integral 2x tends to 2 from right side, its integral part is 2. And when x is 1 plus, it is still negative because x is just greater than 1. So, x minus 4 by 3 will be still negative. So, its signum is minus 1. So, right hand limit is equal to minus 2. Now, left hand limit. As x tends to 1 minus f of x is equal to, we have to take this definition. If x is just less than 1, then what is the fractional part? What is the limit of this fractional part? It is 1 plus 1 by 3, its fractional part will be approaching 1 by 3, is it not? So, it will be 1 by 3. If x tends to 1, integral fractional part of x plus 1 by 3 will be approaching 1 by 3. 1 by 3 into, what is this? If x tends to 1, sin pi x tends to 0, and integral part of 0 is, and 0 from right side or left side. If x tends to 1 minus, pi x tends to pi from left side. So, if you look at the graph of sin x at pi, this is pi. Pi x is approaching pi from left side. So, sin pi x will be approaching 0 from right side, it is above 0. Okay. Therefore, its integral part is 0. Okay. So, left hand limit is 0. So, right hand limit is not equal to left hand limit. So, function is discontinuous. So, no need to check the differentiability. It is discontinuous, but where is the neither continuous nor differentiable. Option 3 is correct, right. Next question. Yeah. Find the number of points where f of x is equal to sin inverse of 2x by 1 plus x square is not differentiable. F of x is equal to sin inverse of 2x by 1 plus x square. We have to find the number of points where it is not differentiable.
Think it is what?
Quickly differentiate it. F dash x is equal to what is the derivative of sin inverse of 2x by 1 plus x square? 1 by square root of 1 minus 2x by 1 plus x square whole square into derivative of 2x by 1 plus x square, 2 u dash into v minus u v dash is 2x into 2x 4x square by 1 plus x square whole square. Okay. Now, simplifying it, 1 plus x square cancels, we get 2 minus 2x square, that is 2 into 1 minus x square by, here after cancellation of skeleton d square, this becomes root over 1 plus x square whole square minus 4x square, and here one more 1 plus x square will be remaining. What is this? Observe it. It will be 1 minus x square whole square. So, it is 2 into 1 minus x square by square root of 1 minus x square whole square will be mod 1 minus x square into 1 plus x square. Now, for what values of x it is not defined. For x is equal to plus or minus 1, it is not defined, you are getting 0 by 0. Yes. If x square is not equal to 1, then you can cancel these two. Then you will be getting 2 by 1 plus x square, it is defined for any real value. So, f dash x is not defined at x square is equal to 1, when x square is equal to 1, or x is equal to plus or minus 1. So, number of points where it is not differentiable is 2. Answer is 2. Next question. Next question. Yeah, this is a nice question. Find the number of points where f of x is equal to limit n tends to infinity, limit m tends to infinity cos power 2m factorial n pi x. Number of points where it is continuous. Here m tends to infinity. So, cos theta, say this is theta, cos theta power infinity. Cos square theta lies between 0 and 1. If it is between 0 and open 1, excluding 1, if the base lies in the interval, if cos square theta lies between 0 and 1, then cos square theta power infinity will be 0. Any number less than 1 power infinity tends to 0. If cos square theta is equal to 1, then exactly 1 power infinity is 1. Okay. So, we need to know when is cos square theta equal to 1 and when is it between 0 and 1. If cos square theta is equal to 1, what is the value of theta? You know that theta is n pi. N pi, no? Some n pi or k pi. Okay. If cos square theta is 1, theta is some integer into pi. So, when x into n factorial is an integer, then the cos square theta will be equal to 1, then 1 power infinity is 1. Okay. When is this n factorial into x an integer? N factorial is n factorial into x. N factorial is 1 into 2 into 3 into 4 into and so on till infinity, because n is tending to infinity, into x. It should be an integer. Then for what values of x will this be an integer? You can easily say that x must be rational. If x is some rational number in the form of p by q, then automatically q will cancel out, because definitely, because it is 1 to infinity, q will be present definitely. So, q will get cancelled, then this becomes an integer. So, when x is a rational number, it is 1 power infinity 1. Otherwise, means when x is irrational, cos square theta lies between 0 and open 1, then cos square theta power infinity will be tending to 0. So, finally, if I take this function as f of x, then f of x will be 1 when x is rational. If x is irrational, its value is 0. When x is irrational, it is 0. So, if you draw the graph of this kind of function, 0 is rational, so its value is 1. At 0 it is 1. Immediately rational number will be followed by irrational number. So, at irrational number it is 0. Again after irrational number you will get rational number, you will get 1. You will be getting one point here, another point here, no two points will be connected to each other. So, this kind of function is called Dirichlet's function and it is discontinuous everywhere, nowhere it is continuous. So, the number of points where it is continuous is 0. So, the answer is 0. So, with this we are going to close the session for today.